Welcome to session 3. In this session, we are going to discuss about introduction to metamorphic rocks, agents of metamorphism, kinds of metamorphism, classification of metamorphic rocks, and descriptive study of metamorphic rocks. First, coming to metamorphic rocks. Metamorphic rocks are those rocks that are formed as a result of transformation that takes place in the pre-existing rocks. So, pre-existing rocks, it may be igneous or sedimentary rocks. So, in other words, we can also say metamorphic rocks are rocks that are formed as a result of alteration takes place in the pre-existing rocks. The word metamorphism comes from the Greek word meta means change, morph means form. So, metamorphism means change in form. When the pre-existing rocks are subjected to higher temperature, pressure, and chemically active fluids, the minerals present in the original rocks changes to a new environmental condition. This adjustment process continues until the minerals attain a stability or equilibrium. By this, original minerals get recrystallized and the original structure and texture also changes. This process by which the metamorphic rocks are formed is known as metamorphism. Next, coming to agents or factors of metamorphism. So, temperature, pressure, and fluid are the main agents responsible for the metamorphism. First one is temperature. So, temperature is responsible in bringing the recrystallization or reconstitution of the original minerals into newer ones. Here, there is a no addition or subtraction of minerals from the rocks. The metamorphic rocks taking place between the temperature of 300 to 800 degree centigrade and even up to 1000 degree centigrade. Second one is pressure. Pressure is also one of the important dominating factor in metamorphic rocks, and the majority of the rocks it is associated with temperature. So it is of two types. First one is load pressure and direct pressure. When come to load pressure, here the pressure acts generally in a vertical direction due over burden resulting change in the structure of the rocks. When come to direct pressure, pressure is from different direction resulting change in volume. That means differential stress. Rounded grains become flattened in the direction of maximum stress. So you can see in the picture here the rounded grains are subjected to uh, stress. As a result, they are get flattened over here. Flaky elongated minerals have preferred orientation in the direction of maximum stress. In the picture, you can see the flaky minerals are arranged in random manner. So, due to stress, the orientation in the direction of maximum stress takes place in the grains. Next one is fluids. Any existing open space between mineral grains in a rocks can potentially contain a fluid. The chemical solution, gaseous and vapors plays an important role in the metamorphism, which is normally associated with temperature and pressure. The chemically active fluids facilitates recrystallization of original minerals due to rise in pressure and temperature. Water is the most important chemically active fluid here. Next, metasomatism. That means sometimes fluids present around the rock comes in contact with the minerals at high temperature, producing many changes in composition and structure. So this process of rock minerals alteration by the agency of solution is called as metasomatism. Next, coming to kinds of metamorphism. Depending upon the factors responsible for metamorphism, different kinds of metamorphism are noticed and they are as follows. First one is thermal metamorphism. Second one is dynamic metamorphism, and third one is dynamothermal metamorphism. First, coming to thermal metamorphism. Here, temperature is the dominant factor, and pressure and fluid are the subordinate factor. When the thermal metamorphism occurs in the immediate contact of igneous intrusion, it is called contact metamorphism. And when it occurs on a regional scale at depth, it is called as plutonic metamorphism. As a result of thermal metamorphism, recrystallization of original minerals takes place. For example, limestone, when subjected to thermal metamorphism, it converts into marble, and sandstone, when subjected to thermal metamorphism, so it converted into quartzite. Coming to second one, dynamic metamorphism. In this type of metamorphism takes place in the rock by means of direct pressure or stress, which is a dominant factor which leads to the new structure. Here, pressure is the dominant factor. It is also called cataclysmic or kinetic metamorphism. And the rock undergo mechanical breaking down, and they may be crushed into smaller one by pressure. For example, shale, when subjected to dynamic metamorphism, it converts into slate. Third one is dynamothermal metamorphism. It is a kind of metamorphism where temperature and pressure are the dominant factors which operates upon pre-existing rocks. The metamorphism may be regional or local scale, and it is called as regional metamorphism. Here, temperature promotes recrystallization, as in the case of thermal metamorphism, and the original mineral grains rearranged into new minerals. Direct pressure or stress leads in the formation of new structures. Thus, the minerals developed under direct pressure are usually flat, tabular, and flaky in nature. For example, granite, when subjected to dynamothermal metamorphism, it converts into gneiss. Next, coming to classification of metamorphic rocks based on foliation. So, based on foliation, metamorphic rocks are classified into foliated rocks and non-foliated rocks. Coming to foliated rocks, the rocks that can split up into thin sheets are known as foliated rocks. For example, slate, schist, gneiss, etc. So these rocks we can split into thin sheets, that is called as foliated rocks. So next one is non-foliated rocks. So these are the rock that cannot split into thin sheet are known as non-foliated rocks. Example is marble. So here mainly these rocks are made up of equidimensional minerals. So that we cannot split into thin sheets. That is called as non-foliated rocks. Next, structures of metamorphic rocks. First one is slaty structure. Slaty structures are also called as a slaty cleavage, which has unique property of splitting into thin sheets. So we can see in the picture here slaty cleavage that shows the arrangement of grains. Next one is cystose structure. It is formed by parallel arrangement of flat, tabular, flaky minerals and tendency to split readily into flakes. So, in the picture, you can see the cystose structure. Here, it is made up of uh, tabular, flat minerals. They are arranged in flat or parallel arrangement. They are arranged in parallel arrangement. So, you can easily split into thin flakes or sheets. Next one is Nisos structure. We can say it Nisos texture also. These structures exhibit alternate light and dark color mineral as bands. So in the picture, you can see the Nisos structure. Here, alternative bands of dark color and light colored minerals are arranged. In other words, we can say the arrangement of flaky minerals and equidimensional minerals. So these two minerals are arranged in a parallel bands, that is called as gneissic structures. Next, coming to descriptive study of important rocks. First, coming to gneiss. So color. So normally it is gray color, banded, etc. You can say it is leucocratic. Texture. When come to texture, it shows gneissic texture, or we can say parallel orientation or alternate banding, like that. Normally it is fine to medium grained in nature. When come to mineral composition, essential mineral is quartz, orthoclase, biotite, same as granite. Accessory minerals is hornblende, iron ore, etc. Specific gravity is 2.7. Crushing strength is very high. When come to origin or occurrence, a foliated rock formed by the regional metamorphism of sandstone, conglomerate, granite. So, mode of occurrence depends upon the parent rock. Thus, it may occur like large-sized igneous body or massive bedded formation. Coming to classification, here it is dynamic metamorphic rocks. Next one is important uses. Normally, it is used as building stones, facing stones, decorative stones or decorative purpose, and also it is used as road metals, concrete aggregate, railway ballast, pillars. It is used for pillars, slabs, etc. So it is also used same as granite. Next one is slate. So color of the slate, it is gray, dark gray, black, red, etc. So depending upon the uh, clay mineral and also cementing material, we can say melanocratic. When come to texture or grain size, it is normally shows compact, fine grained texture, and also it shows slaty cleavage. Slaty cleavage and cystose. When come to mineral composition, essential minerals are clay minerals and also chloride, quartz, feldspar, etc. Accessory minerals are iron pyrite, mica, magnetite, hematite, etc. When come to specific gravity, it shows 2.8 to 2.9. Crushing strength is medium. When come to origin or occurrence, it occurs like shales as bedded rocks. It can be distinguished from shale by its toughness. So it gives a uh, sharp sonorous sound produced when two pieces are struck with each other. It's a dynamic metamorphism of shale. Classification: dynamic metamorphic rocks. So important uses are slates are soft rock. We can easily cut into sheets and pieces. So we can use it as flooring, roofing, and blackboard, etc. Mosaic granules, interior and sanitary works, we can use this slate. So next one is marble color is white, green, black, multicolor. So normally pure marble is white in color. When it is hardened with some impurities, it gives color. It may be greenish, blockish, like that. Texture is granular, fine to coarse grind. When come to mineral composition, essential minerals are calcite or calcium carbonate. Accessory minerals are quartz, iron ore, garnet, serpentine, etc. Specific gravity is 2.7. Crushing strength is medium. Origin or occurrence, it is contact or thermal metamorphism of limestone. So the original rock is limestone. It when limestone when subjected to contact or thermal metamorphism, it gives to marble. Next, classification. Thermal metamorphic rocks reacts with dilute HCl. Important uses. Normally, marbles are used as architectural, ornamental, decorative, and monumental purposes. So, and it is also used mainly in for flooring work and staircase, etc. Next one is quartzite. So, color is white, gray, pink, brick red, etc. Texture is fine to coarse grained in nature. Mineral composition, essential mineral is quartz, accessory mineral is mica and iron ore. Specific gravity is 2.7. Crushing strength is high. Original occurrence. Thermodynamic metamorphism of sandstone. Sandstone, when subjected to thermodynamic metamorphism, it gives quartzite. Classification. Regional or thermal metamorphic rock. Important uses are road metals, railway ballast, glass making, etc. Next one is muscovite and biotite schist. It belongs to metamorphic group of rocks formed by the dynamic metamorphism of shale. So it is composed of minerals like muscovite, biotite, augite, hornblende, chlorite, etc. depending upon the presence of dominating mineral in a rock. Normally it shows schistose structure or texture. If the biotite mineral is dominant, then we can call it as biotite schist. If the dominant mineral is muscovite, then we can call it as muscovite schist. So this is about schist. So next, come to after descriptive study of the rocks, come to course outcome. So in this session we have learned about metamorphic rocks, metamorphism, agents of metamorphism, kinds of metamorphism, classification of metamorphism based on the foliation, structure of metamorphic rocks, and descriptive study of gneiss, slate, marble, quartzite, and schist. Next, some of the important multiple choice questions in this session are as follows. First one is, which will be the parent rock for metamorphic rock? Options are sedimentary rock, option B igneous rocks, option C metamorphic rocks, and option D all of these. Second question, quartzite is a metamorphic rock composed of a dense network of interlocking. Options are option A dolomite, option B quartzite, option C calcite, option D epidote. Third question, marble is a metamorphic rock that forms from a dash parent. Option A granite, option B limestone, option C shale, option D sandstone. Question number 4, which mineral is responsible for the strong foliation in a schist? Option A quartz, option B calcite, option C foliate, option C mica. Fifth question. The foliation in a slate is called slaty. Option A cystosity, option B cleavage, option C mesosity, option D foliage. Thank you.